All right, now we're going to learn about fine-tuning. And as of recording this video, it literally just came out yesterday, so you're getting this fresh. The API for OpenAI's 3.5 model is pretty straightforward, actually. And they have some details on the documentation and also the blog post where they came out with fine-tuning as well. I've just followed along with the example here, but I'm going to explain to you what's happening at each stage. The first thing you need to do is get your data into the right format. If you're following along here, you can make a copy of this. My data from my blog is here, and you can open that up. I'll just show you what that looks like. This is the format. So it's called JSON-L, which is like JSON, except every object is on its own line. So you can see there's no parent object. And it just is a list of messages. So the messages are the system message. I've just kept that default, but if you're testing fine-tuning for yourself, you already have a prompt that's working in the system message, you might want to use that prompt here. I've just gone with the default. And I think it takes a lot of experimentation, but you might get better results if you update the system message. Equally, I've just used this really simple prompt, which is write the section and then the section header for the blog post and then the blog title. What I've done is I downloaded all 48 of my blog posts. I split them into sections based on the section headers, the H1 tags. And then I've put the name of that section into here, and then the blog title here. Like the AI is then responding. So obviously the AI didn't really respond. This is what I'm telling you, it should have responded. So that's how you're training it. You're saying like when the user prompts like this, then give me this type of content. And my hope is going to train it to talk like me. So that's the actual section text there. So getting into this format is the first challenge. It's actually like probably the hardest thing. What I did actually is I cheated a little bit and I used the code interpreter. I'll just show you kind of how I did that. I uploaded the blog posts and then I just asked it to prep it into this format, and I gave it one example. I just said prep into the format, write the section header for the blog post article title, and make sure you cover all the blog posts in the CSV. And the format is like this. I gave it one example. I just took a section header, why must agencies charge so much, for one of my posts, and then I pasted in that text manually. Cool. It actually did all the work, and I'll include the code that it used. So I asked it to, one thing is initially it had a bunch of HTML in there. So I asked it to get rid of that. But other than that, it worked really well. And I asked it to package up all the code. So I'll include this as a .py file. So hopefully you should be able to just run this, or you could give this to code interpreter and say, can you do that for my data? Cool. And then once you ask it to generate its output, you can click and save the file. Cool. So that's how you get the data in the right format. This is how you load my data. So if you just want to test, you can load this from this link. It's just extracting the file ID and then pulling the data and then saving it locally. And then this loads the data, so you can see I have 304 observations. Typically with fine-tuning, what OpenAI says is you probably need at least 50 observations in order to start noticing a difference in the model. And I've seen in a few papers that it's typically around like 200 observations that you need in order to get to the point where fine-tuning actually shows better results than just general prompt engineering. So I would say if you have 200 samples, then you're probably in a good position to start fine-tuning. If you're not in that position, then try and generate 200 samples manually by getting people to label them, or you labeling them, or you could just use prompt engineering for now, and then once you get to 200 samples, then you can do this type of work. The code here, basically I just need to get the OpenAI key. You can paste that in there. You can get that in here, view API keys, and you can create a new one. And then this is the call to the OpenAI fine-tune. I guess this specifically is like the files section. So before it can fine-tune on your data, it needs to have your data, right? So this is just a way of uploading that file to OpenAI. And this basically just splits it and opens it in a file path. And then you get a response that says, here's the file ID. here's how big it is, and it was uploaded. Now, one thing I found is that sometimes with larger files, it takes a while to upload. So if you try and run the rest of the code, it doesn't work. So I've added this section here, which is just checking on that file. And it just, if you run that, and then it just finds the latest file that you uploaded. And then once it says processed, then you're pretty happy. Then you can keep running. Then you start a fine-tuning job. So again, pretty straightforward. Just call the fine-tuning jobs API, again with your OpenAI key. And it is recommended that you train on this GPT 3.5 Turbo 0613. The reason is that they don't support GPT-4 fine-tuning yet, although they said it's coming in the fall. You can also tune on to other models, but they're the older models like GPT-2, so it's not really worth messing with. Or at least, not for most of the tasks that I've found helpful for. Cool. So when you call that, then you get a job ID, and you can see that it's not finished yet, and it says status created. And again, you can just check the status. So if you run that a few times, it will say running. If you scroll across, and then eventually it'll say status succeeded. And once it has succeeded, then you can see how long it took. In this case, it took 24 minutes. And then also you can calculate the price. So you can calculate this ahead of time, but the cost for fine-tuning is a tenth of 8 cents per 1,000 tokens. So it cost me $2.22 to train on these 300 observations. And then you get the actual fine-tuned model itself. So you can see that here. This is my specific code. It shows up in my account. And then you can just query it just like you otherwise would. And so this is just a normal query to OpenAI, except I'm passing this new model name in. And I think it's really important that you keep the system message and the prompt style the same. But I'm getting, I think, pretty good results. So this actually really does sound like me, I think, if I scroll back to the beginning. It uses a lot of the same kind of informal language, but quite direct, not much fluff. Yeah, like words like under the hood, I use that quite a lot. Yeah, here we go. I think I'm using figures and stuff like that. Yeah, I think I'm actually pretty impressed with the results. And then the other thing I think you should think about is this was asking it to a section that it already trained on, but really you want to try and write a section that it hasn't trained on. So here's a topic that I have written about memetics. I actually wrote a whole book about memetics, but there's only one blog post on memetics on my personal blog, and it doesn't mention criticisms of memetics. So this is a tangential topic, and I haven't written specifically this section, why isn't memetics a science? So this is a better test, and what I find is it still sounds like me. It starts to quote different people I've never read, but it's still doing a pretty good job. So I think that more testing needs to be done. Ideally, what you would do is you would hold back some test data when you have the 300 or something samples. If you held back 10-15% of that, and then you could feed in those prompts, generate, and see how well they did relative to the real task. So I would say that's good. That's a good idea really with any machine learning. But yeah, that's how you're going to really tell whether it's done a good job. You can also tell programmatically. So there's the evals functionality in LangChain or in OpenAI. You can do manual kind of blind thumbs up, thumbs down. Does this sound like me or not? Sentence by sentence. You could also do embedding distance. You could calculate the vector for the text, the reference text, the actual writing that I did, and then calculate the embedding for the text that the fine-tuned model generated, and then see what the difference is, see how close it gets. And you could try different fine-tuning techniques. So you try with a different system message and see if that improves things, and so on. So it is an iterative experimental process. The other thing to show you is that these models, there's not much interface, unfortunately, with these things, but these models do show up. So if I refresh, and then you can see I have my fine-tunes that show up here. If I want to say the section, what is my favorite color? Just a random one, just submit. See what it comes back with. Yeah, so it doesn't always work. I think if it goes off piste in terms of the examples, it doesn't do as good a job. Cool. The other thing to talk about is the pricing. Here we go. For fine tuning, it costs like 8 cents per thousand, or less, sorry, 1/10 of 8 cents per thousand tokens to train, and then it costs like basically 1 cent for input and 1.5 cent for output when you're talking to the model. So if you compare, this is what GPT 3.5 normally costs. So you can see that we're going from 0.0015 to 0.012. So it's an order of magnitude different in terms of cost, but it's still pretty cheap, right? If you think about GPT-4, that's 3 cents and 6 cents per token. And so you're basically getting a much cheaper model than GPT-4. And what a lot of people have been telling me is that you can get better results with a fine-tuned GPT 3.5 model for specific tasks than you can with a general GPT-4. So it depends how you position it. It's either a really expensive GPT 3.5 or like a really cheap GPT-4 replacement for some tasks. So yeah, hopefully this is useful for you guys. Again, this is like really new, so this might change, but hopefully you understand the kind of thinking behind it and how it works. And what's really great about this is it's pretty accessible. You don't have to be a machine learning engineer to do this. Like I'm certainly not. So hopefully you guys can experiment and find some interesting stuff.